Can I get a show of hands of anybody that has ever coded .NET in PowerShell? Um, yeah, before I did this session, I really didn't know much about .NET. I kind of coded .NET out of necessity because of what I needed to do. I had a problem that I needed to solve, and I am no way near a .NET expert. It's just one of those things where I needed to get something done, and I'm just going to show how I solved this problem. So if you know a lot about .NET, I apologize if you already know a lot of this stuff. So, but let me go on. Good shout out to the sponsors that helped make this PowerShell conference possible. Who am I? I'm Bruce. I work at Everwise Credit Union. I'm system administrator. I take care of application extender, which is a document management program for our document archival systems. SMA OpCon, which we just implemented this past year, which is for automation of our financial core, and PowerShell, which I do a lot of integration with SMA OpCon and application extender. Now, Everwise Credit Union, this is my second year giving a speech. Actually, last year, when I gave this speech, we were known as Teachers Credit Union. And now we did a lot of rebranding because obviously we are also known as TCU. So there's a lot of acronyms of organizations known as TCU. So we went through rebranding, so we won't be known as something else as TCU. So now we're known as Everwise Credit Union. Here's the QR codes for my social media and Everwise Credit Union and my LinkedIn. And I have, my next slide will be for my slides for document, or for the slides in this presentation. If you don't get it, that's fine, because it'll be on the last slide also. And also my LinkedIn, along with the survey on the last slide. But I have the GitHub page for that also. For the agenda, we'll go over asynchronous processing, which is going to kind of help lead up to RunSpaces. If you're not real familiar with .NET, which is kind of what you need to kind of understand in order to do RunSpaces. And then we'll go into .NET PowerShell, and then RunSpace and RunSpace pools. And lastly, we'll go into a demo, but we'll also have a few demos throughout the presentation to help things move forward. What is synchronous processing, or why do you care about synchronous processing? Well, the way I think of asynchronous processing is to just make things go faster. Why else would we want to? I mean, as fast as things move forward, hardware gets faster. I've always come to realize that no matter how improved our hardware gets, bad programming can still make things go, or can make our scripts or programs slow down. And I've found that the hard way. And there's always good programming skills to help make things go faster. And .NET RunSpaces is not a one-size-fits-all. You're going to realize that there's pros and cons of .NET or RunSpaces. And it's just another tool in your tool belt, or another option that you can use that might be a benefit to you. Synchronous versus synchronous processing. PowerShell is a synchronous-based scripting language, but it also has ways of performing asynchronous processing. So Ways to create asynchronous processing. These are not the only ways of creating asynchronous processing, but here's some of the top ones that I know about. One is jobs, which you just create processes in the background. Another one is reacting to events. Now, we do some of this stuff in SMA OpCon, but the easiest thing I think about with reacting to events is file arrival. A file arrives in a directory, it reacts to an event. For example, we have automation processes that arrive into a directory. Of course, you can just create a scheduled task at, say, a certain time, and then when it sees a file, it just reacts to it. But you may not know when that file arrives. Why you just want to create a process that just waits at a certain time when you just have a service out there or a PowerShell script that reacts to an event whenever a file arrives. And then .NET RunSpaces, which is what we're going to talk about. And then unfortunately, for each and start threshold. Those are only in PowerShell 7. And when I had to resolve this issue, unfortunately, we're in Windows Server, which only has PowerShell 5. And these for each and start threshold is in PowerShell 7. There is a way of doing it in PowerShell 5, which is workflow, which uses for each and I believe a dash parallel. But unfortunately, that was deprecated in PowerShell 6 and later. .NET and PowerShell. The following topics we'll cover in .NET for PowerShell. We're not going to cover everything in .NET. These are just some of the top topics because we could spend all day talking about .NET. So some of them are namespaces, types, classes, and assemblies. Namespaces I just like to think about is ways of organizing stuff, basically, or your types or whatever you want to think about. It's just like a folder. You're just organizing it. Now, basically in PowerShell, you can put namespaces in brackets. Of course, you just put them in brackets, you're going to get an error, but in this case, I just put it here just as an example. Namespaces, you're going to need to have a type with it, and we'll see that later. So it'll be like namespace, period, type. And then we have types. I like to think of types and classes basically the same thing. Types describes a functionality of an object. Oop, I kind of skipped over that slide. I got ahead of myself. Okay, so list.name namespaces. Okay, this is a command that lists all your namespaces on your computer. Not necessarily to memorize a command, but I just thought this was interesting to put out there to list all your namespaces if you want to see what's out there. But there's an easier way of doing this. If you want to look up what your namespace does, there's a .NET API browser. See if this works here. Okay, here's a .NET API browser. I see it on mine, but not on that one. So there we go, .NET API browser. So here's where you can look at all your .NET namespaces, which is a very good resource because you can look up what classes, properties are in it, a lot of other information, but I usually look up a lot of classes or properties in there, which is how you can interact in PowerShell. So let's say we want to look up system. Diagnostics. For that, this is for like the commandlet get dash processes. So we can look up the namespace system.diagnostics. Or we could, that's the namespace, or we could look up the, there it is, the class system.diagnostics.process. And then just bypassing all this stuff, because what I'm looking for is there's properties and methods. And you can see how that comes more into play later, but this is a really good resource for all that. So, okay, this is where I got ahead of myself. The .NET types represents the functionality of an object. And then this is what you need to type in at the PowerShell command to get an object back, would be your namespace.type name. So when I typed in at the API browser system.diagnostics .process, that would be system.diagnostics would be your namespace, then process would be your type name. And we'll see that a little more in depth here shortly. So then classes, types and classes are so close to the same thing, almost. But classes are instructions for creating an object. But the funny thing about it is classes, when they're compiled, becomes a type. So, and then classes also have methods. So if you wanted to list or have your method, you'd have, after your namespace and type, within brackets, you'd have 2 colons, and then your method. And then, so it'd be like, for example, if we were looking at our processes, for like get-process, it'd be your namespace, which would be system.diagnostics, and your type name would be processes, then colon, then your method for that class, which would be like get processes, for example. And then list namespaces. This is kind of a convoluted command, but here, basically what we're doing is you got app domain, which is your type name. Now, if you're currently in your namespace, you don't need to type namespace. You only need the namespace if you need to find that location. So in this instance, we're just typing the type name. So it's system.appdomain, but since we're already in that namespace, we just type in the type name app domain. Okay, current domain, which is the property, get assemblies, which is method, get type, which is the method. And then we're just using where object, namespace, or the $_ namespace. And then the system.io, just replace that with what namespace you're looking for. And that'll get you the classes of the namespace. And then I'm not going to go back to the API browser because I had so much trouble before, but that's basically the same API browser as before. You just go to that API browser and look up your classes or your namespace or whatever you want to, and it gives you all that information for that namespace. Or look up the classes or the properties. Now, .NET assemblies. .NET assemblies can be static or dynamic, just basically a collection of types. And if they're dynamic, they create in memory. If they're static, they are basically DLLs. And here's how you find out where the DLL is located. Here's your namespace, type name, .assembly location, or .location. You can find the DLL for that namespace, or type name. And for the .NET demo, just a second here. Okay, here we'll list namespaces of computers. Some of this stuff is what we went through over the through the presentation there. Okay, here's that whole command. Of course, here we're just looking at the first 20 objects, because if we didn't, it'd just scroll off the screen. And here's our namespaces on the computer. Now we're just going to look at the object of the namespace and type. So here, it's a system.text namespace with the type name decoder. And nothing special about it. I'm just taking random namespaces and type names, just to give an example. Now, if you want to look at what the namespace is and type name, because it may not always be the first couple words for namespace and the last word for the type name. So if you want to look at, okay, which part of within the brackets is the namespace, you just do whatever is in the brackets and do period namespace. And it would give you the namespace, which in this instance is system. And if you want to do type name, it's dot get type info. Left parenthesis, right parenthesis, and that'll give you the type, which is app domain. And then for type name of a commandlet, now here's the interesting thing. If a lot of people don't realize that all commandlets are based off of .NET. So if you do get dash member, it's basically listing properties and methods off of a commandlet. So if you do get dash member, I'm just doing select 20 because if I don't, you won't see the top part of it because it'll roll off screen. You can look at the actual type name of the commandlet. And that's the top part where it says type name system.diagnostics.process. That's the type name, .NET type name of the commandlet. So if we were to, if that's the .NET type name of the commandlet, why can't we just type that .NET on the command and get the processes? One thing is if we type the .NET, we're just going to get the object. It's not going to work. We just get the object. So what we want is the method. We don't want just the object. So, for example, if we do get dash member, now we got where object with name like get p. Now the reason I'm doing that is because I'm just trying to show you an example. We're just looking at get process because that's the method that actually does the process, looking up all the processes. I mean, I could just looked up or did everything, but in this instance, the reason I'm showing you this is because there's no get process here. There's only a get property and get properties and get property. The reason is because if you do get dash member, it's only giving you the properties and methods of instantiated objects. We don't want that. We want the properties and methods of the class in order to find the method. So if we do that, we want to use get member dash static to find the static methods. Okay, now, see right here we got get processes right here. That's what we're looking for, that method. So now, we got get, just show you the example here, we got get process, select first 20. Now I'll show you the first 20 of the processes. We do the same thing in .NET, system.diagnostics.process, 2 colons, get process method, select first 20. We get the same thing. So we need that method. If we just do the type name, we're just gonna get the object. Now this example, we're just going to show the classes of the namespace, which is the same example we've shown in the PowerPoint. And yeah, I didn't do select 20, so it just shows everything basically. Now here, we're going to list the assemblies. So we got system.appdomain, current domain, get assemblies. That's going to show us all the DLLs. But there's another way of doing it. There's, from PowerShell Gallery, there's a module called Class Explorer, which can do the same thing. Now, I already have this on computer, so for an example, I just put in a string, just show you what's called. So I don't need to install it and import it. But it's called install module Class Explorer and import module Class Explorer. But then the module is called get assembly. And that'll get you a little bit different this output, but it basically does similar stuff with getting you the DLLs. So then we can actually look for the PowerShell assembly, which gets loaded every time you open up a PowerShell console. So PowerShell, when you open a PowerShell console, it creates a run space every time. Run space, all that is just an environment to execute commands. That's all it is. So whenever you open up a PowerShell console, it executes or runs a DLL. So all you got to do is run the .NET System Management Automation PowerShell.assembly.location. And I'll show you this DLL gets loaded every time you execute PowerShell. Well, actually, this is for PowerShell 7. But. Okay. I just got to find the mouse. There we go. So now I'm to create a .NET run space. So create PowerShell run space. When PowerShell starts, it creates a run space. But you can create your own run space. So if you, for example, we just went over this in the previous example, PowerShell Management Automation PowerShell. That namespace and type name gets run every time you open up PowerShell. Now, we don't have to run the namespace System Management Automation because you're in that namespace every time you open PowerShell because that gets loaded every time. So you could just do PowerShell in square brackets. That does the same thing. So now, in order to create a namespace, it's just PowerShell, : create method. That creates your run space. So methods for the namespace. These aren't all the methods, but these are more common ones that I encounter. You have the add command. All the command is basically a commandlet. So you put in get whatever, invoke whatever you want. Now, the interesting thing is add parameter, because add parameter isn't exactly the same as in a commandlet, okay? Because the parameter part is whatever value you want, but the parameter name is the same as what the parameter name would be for the commandlet, but without the dash, which is kind of interesting. So same thing, but you just have to make sure you remove the dash. And add statement, think of add statement as a pipe. You're just connecting multiple commands. And add script, that could be a file, could be a here script, just in a variable if you want to execute as a script. And then a couple more is just invoke and begin invoke. Invoke means execute this now. Begin invoke, run it in parallel. Example run space creation. Here's an example of creating a run space. So basically the periods are just connecting the methods and properties together. But you have PowerShell create, add command, get process. Now if we ran just the commandlet, name would be dash name PowerShell, which we're looking for the PowerShell 7 process. But since we're in .NET, we remove the dash, so it'd be just name and invoke. The bottom one is an example of a here string. So we're just putting it into a variable, PowerShell create, add script, invoke, with the variable script in there. And it's pretty much as simple as that. This one is interesting. because it doesn't take much more to do a RunSpace pull. And RunSpace pull is just, all it is RunSpace factory type, create RunSpace pull. 1 would be the minimum number you want to run. 5 would be the maximum number you want to run at the same time, that is. And then you open the RunSpace. Okay, so when you create the RunSpace, there's a property called RunSpace pull. Okay, so then you add to that RunSpace pull the RunSpace pull that you created up at the top line. And then, unfortunately, with RunSpace pulls, you want to make sure you deallocate. Yep. It's just an object, if that makes any sense. It's just basically you just create a RunSpace pull. It's just another object, a .NET object that you're creating. Run things in parallel. Actually, you'll see that here shortly because I got an example of a RunSpace pull. Basically, what you're doing is, let's say you have 100 processes you want to run, but you don't want to overwhelm your system. But you want to run maybe 5 in parallel at one time. And once those 5 finish, run the next 5 in parallel, and the next 5, etc. You don't want to like overwhelm your system. Or actually, I got an example here.
Where's the RS variable come from?
Yeah, RS variable. I don't have it here, but RS would be the RunSpace. So let's see if I can back up.
Oh, like the PowerShell one you created?
Yeah, right here, like when you create a .NET RunSpace pull, the RS would be here. I didn't have it in the actually that example because it'd take up a lot of space. So it'd be like RS would be the RunSpace, and then what you're doing here is the RunSpace pull would be added to the RunSpace. I should have probably added that in there. So like the RunSpace, you create the RunSpace, and then actually this one and this one here is the RunSpace pull, and you add it to the RunSpace.
So you create, like in this example, 5 of those PowerShell RunSpaces and assign each of the RunSpace pool.
Let's see if I can back up here. So if I go, see here, so like, it'd be like right here. So say, for example, RS equals PowerShell create right here. Of course, this would be a little bit different code here. It wouldn't be like get dash process. It'd be something different here. But it'd be like RS equals PowerShell create for that. And then you have to create your RunSpace pull to add to the RunSpace. And actually, I have more code that'll explain that. And then, but the thing about it is, once you create your RunSpace pull, you need to dispose of it because it'll be just in memory. So you have to like, if they're jobs, you need to dispose or RunSpace pull dispose or do some garbage collection to get rid of them out of memory. So here's a good example here. So we have the RunSpace or RunSpace pull, which creates between 1 and 4 RunSpaces, or not really RunSpaces, but like executes 1 to 4, and it opens it. But then here we have, it creates a job between executes 1 and 20, and then 4 each, or 4 each there. Now here's where we go. This would be where, like in that example, that's where the RS would be, but instead of RS, we're using INST, for instance. But when we add a script, we're just sleeping 20 seconds. And the sleeping 20 seconds is just an example, just so we can show. So we're just sleeping 20 seconds. And now here's the example for RunSpace pool adding to, that would be, if we went back a couple slides, that'd be RS here. rs.runspace pool equals RSP. Here we're just creating a custom object, and we're just adding them to ID, the instance ID, the instance equals instance. And here we're doing in parallel, begin invoke. And then here, we're adding this, which is the current instance. The invocation state info, state. So the current state of what the object's in. And actually, I'll run this, this program here in a few minutes so we can see how that works. But basically all it's doing is running them in parallel at 4 at a time so that you won't overwhelm your system.
Question.
Yeah?
What's the maximum number you would suggest to prevent overload?
That I don't know. And then we'll go and look at this here real quick. So look at a RunSpace example really quick. So there's actually a command that called get-runspace. Now, if you don't create any additional RunSpaces, there'll be just one RunSpace out there, which is the one that PowerShell console creates. If you create a lot of RunSpaces, the one with ID 1 will be the one that PowerShell creates. So right now we have, that'll show you your RunSpaces. Now, just look at real quick at the PowerShell structure. Some of this will be repetition that we just went over, but there's object. We just did it again, but without the namespace as an example. Namespace, type, and static for the method. Okay, here we're looking for the PowerShell process. Okay, let's go ahead and look at, let me pull up a VB code real quick. There we go. So just kicked off that process. There it's running. So every, I can't remember if it's 10 or 20 seconds, but 4 is completed. You have to look at every so often. Yeah, it's every 4 or every 20 seconds or so, 4 will complete. Yeah. That's pretty much how RunSpace pools work, just so you don't overload your system and so it doesn't run everything in parallel at once, just every so many that you want to run in parallel. And then, now how I solved my problem is I had been able to get some reports into application extender. And it was taking a real long time, so it's like taking around a few hours long to get in there. So this is the script I use with .NET to get in there. So here, I just use create. I created a module called expand extender text report. So it uses, basically it just looks for text report because it's basically a big report with multiple reports, sub-reports in it, which is a text file. And it looks for that file and uses regex because every report starts with a 1 in the first column. And it looks at that and it splits them out. And if I just did a test, and on the test it was like 1 second for .NET, and without .NET it was like around 3 seconds, whatever. That doesn't seem like much time, but when I went from like 3 hours to around 15 minutes, it was a big help. And the other part of the script, I create a PowerShell RunSpace called invoke extender start index. What it does is it indexes the text files, and it maps them from an index file, which is pipe delimited, to each of the subtext reports. So App Extender knows how to import them into the proper application within Extender. And all the invoke extender start index command just looks for the iReport, which it got that variable from the other RunSpace that we just looked at. But then it looks for the file to process, which is the report that is mapped. There, it looks for the import path, and the file index starts with 0. So it looks for those numbers because it puts them on the end of the file and within the index, so it knows what to look for. And here it was like 33 seconds for with .NET, and without it was like 63 seconds for just a test for like around 11,000 reports. So here, just as an example, here the folder is empty. If I do the first part of the script, there we go. So here we look at there's 25 reports. Oops, wrong one. And it puts them in an array. So here's one report. So each report, well, obviously it's an array, so it's 0 to 24. But that's looking at one report. If I was to it might be easier if I do this. Yeah, it's just one big file. Okay, so if I go to the next part of the script, oh shoot, I was looking at my screen, couldn't see the folder. But anyway, it generated all these files. So if we look at, yeah, it seems 49801, but so it creates all these folders, and then there's the index file that it creates. I'm going to put it on the screen. Shoot. It's very hard to look at the one up there. Anyway, it's pipe delimited, so it's hard to look up there. It's like it has like name, date, title, and then it has like an @ sign, and then the path. It's just hard to kind of look up there and get all that information. So but the thing about it is, I mean, if it's like something really small and quick, .NET is not your way to go, because there's been like, I had like quick scripts and I did time it, and actually your commandlet, or the commandlet I tested, was faster than .NET. You're only going to get your benefit out of .NET if it's something that's really time consuming, long. It's just something you're just going to have, if you're having issues, it's just something you're going to have to try and say, is this better? It's not something, it's just something that's just another option for you to try and see if you're having issues, maybe give it a shot and see if it's something that will work for you. So, I mean, call to action, if your scripts are running long, just use good programming practices. There's been times where my script's running long, I'm doing something simple as I'm writing all my files to a drive, and then I just started putting them in an array, and then before writing them to a file, where memory is faster than your drive, and I see a big performance boost. It's just simple things like that, good programming practices. And .NET might not be, the best solution, but if you're having issues with speed, give it a try, or even RunSpaces. And when I was having an issue, this was like my go-to resource. This was a really good book. If you want to learn more about .NET or RunSpaces, I believe chapter 5 was, I'm thinking .NET, and then I'm thinking 15, I could have it wrong, but I think 15 was asynchronous processing, where RunSpaces was inside the chapter for asynchronous processing or something like that. But if you're interested in any more information, that was a really good book. And then if you want to miss any more information that you want to get or learn more about from my slides, there's a QR code for documentation, which is on the GitHub. There's my LinkedIn, and there's a survey. Last year was my first time, and I found those very helpful, making me a better presenter. But thank you for coming, and if anybody has any more questions. So.